November 25th, actually the 26th. Happy Thanksgiving in the greenhouse. Setting up some new thermal mass tanks here. These two are going to come from a separate pump that will pump off of the secondary mass reservoir. It'll pump out of that through this tube here that runs around the bin and into the barrel, and through the barrel, hot to cold, cold out the bottom. That will come over and come into the beds for heating underneath the plants. I dug up some garden hose that I had laying around because it doesn't cost me anything, and scrounged up some fittings from around the farm. And I'm probably not going to put the coil in tonight. I got it in here by the stove just to warm it up, make it a little more flexible and workable. And then probably tomorrow I will lay the coil in here in the bed, and then I will fill over that with more of those wood chips as a way to distribute that heat nice and evenly and give a little bit of a padding. And then I'll finish rigging up the pump and that side of it, and then I'll have to pump some more water up here. Probably just bring on the foliar pump and fill the system from that. But excited about the new thermal mass system. I guess I'll just show in the back here, I took 2 pieces of 2-inch styrofoam insulation and stacked them behind these, and then I just crammed the barrels tight against them to help give a thermal bridge for that back wall, so we're not losing heat out to the wood chips and other stuff. Even though there already is a layer of insulation behind that, I figured a little extra insurance wouldn't hurt up against the thermal mass barrels. So, and I finally opted to just let the aloe vera have this space and the soil that I dug out to settle the barrels in. I put on top of here. So I'm going to let the aloe vera just grow here. I think it'll be pretty happy next to the thermal mass, and with good soil and moisture around it. Anyway, a little bit more tubing work to do, a little plumbing work and some coating work, and then we can actually get this part of the system up and running. I'm really excited about this. I've wanted to do something like this for a long time, and I just didn't have all the pieces together. But here we go. Stay tuned. Well, man, you know, I get started on a project and I just can't quit. I took the hose roll out and unspooled it and laid it out to stretch out overnight for a little bit. Quite a few kinks and coils in it, so we'll let it stretch out a bit. And I came back in here and I wired up the new pump and plumbed it, and I didn't rig up on the wiring is to a relay yet. Just want to test the pump and see if that, see how well that works. Don't have the rest of the coil in yet, but have lots of barrel space that needs to be filled with water. So just for pump testing, I'm going to pump some of the hot water into one of these barrels and at least see if this bottom fitting leaks or not. They should be good. I tightened them in, I torqued them in pretty good. I don't know where my barrel wrench is, but I made do with channel locks. Anyway, figure we'll just give it a try here. So let's do just that. The pump is on. Can feel the pump vibrating as it's operating. You can hear water peeing into the barrel. Pretty cool. This system's going to be awesome. So basically, how this is going to work thermodynamically. We got the pot on top of the stove, and with that coil and that pump, we can extract heat to the secondary tank. That gives us a nice 100-gallon thermal mass base. And then from this tank, we can check the temperature of the barrels and the bed. So I'll have to come back and embed temp sensors on the bed, and basically pump hot water from this because this gets to a point where it's so hot that it's hard to take heat off of this. So I'll be able to take some of that heat and sequester it into the thermal mass tanks here, and that'll give us a reserve so that whenever we need to throughout the night, even when the stove is off, there'll be about 110 gallons of warm water sitting here, and that can be injected into the beds to keep the bed temperature up. So that's the theory of operation. And so this is set up so that we're putting hot water into the top of this barrel, pushing all the cold water out, which pushes it over to this barrel. Eventually the hot water fills this barrel and comes over to this barrel and fills this barrel from top to bottom. And then once it does that, then we start pumping, and these loops will come out in underneath this bed. And I have a ton of hose, so I may even loop some over here. I don't know, we'll see. But that's basically how it's going to work, and the new pump is testing out well. That's pumping warm water into that barrel. Probably actually going to have to pop this off and pump into here when I go to really fill these barrels all the way, to break the air bubble out, pump the barrel full, and then switch back out to our proper setup. Alright, I guess I'm done babbling for now. Just kind of playing around. And tomorrow, after family Thanksgiving stuff, I'll probably come back here and finish getting that in and lay some wood chips in on there, and then there'll just be sensors to wire, relay scripts to write, and all that sort of stuff. But the main part of the system will be in. But yeah, I guess I'll just show you quick that we're draining the tank for sure. That's right. Tomorrow I'll hook up the foliar feed pump and jack this tank back full, and we'll get everything filled up, topped up. Alright, November 26th, I think. Thanksgiving Day, 2020. Well, Thanksgiving night. Came in this afternoon before I went over to do family stuff, and drilled a hole in each of the barrels, installed a Dallas Instruments DS18B20 one-wire thermal sensor in each. Excuse me. I know these sensors are good because these were originals that I had from way back that I had tested, and then I had loaned out to my friend Dave, who actually gave them back to me recently, along with that battery. So I'm really stoked to have a couple more sensors. I was going to do an upper and a lower in these barrels, but I realized I don't really need that much precision, and frankly most of the water that's coming through here is going to be pretty uniform in temperature because the pump that's in that tank is going to be circulating that anyway. But I do want to have a general gauge on how many BTUs we have stored in these tanks, so I basically picked the midpoint on the tank and went for a non-invasive, not likely to leak sensor install location. I could, I could go up the whole tank with all different layers of sensors if I needed to, but it's not necessary for what I'm doing. But this will let me monitor, at least what we have in general in BTUs and storage in these two tanks. I do like to have a total assessment of it. And so to fill these, I basically have to fill them from bottom to top because we're filling with water. And if I fill from the top, then we'll have air pockets trapped in there that won't come out. So to avoid that, if we're going to start filling from the bottom, I've moved the line over to the bottom from the pump. I'm going to fill this up, and then I'll switch it back. I'll switch this line back to the top, so we'll be putting hot water in the top and taking advantage of stratification for uniform storage. And then I'll take the line that I use for the crossover between these two, and come out of the bottom of this, go into the bottom of this. We'll fill this barrel, and then we'll put the crossover back in place like it's supposed to be. But sort of a sequence that has to be used to get the barrels full of water. In the process of that, of course, the tank over here is going to be run basically dry. So I'm going to go down and hook up the foliar feed pump at the reservoir and send water to the upper reservoirs in the barn. And in the process of that, I'll be refilling this also And I'll probably top this up, top that up, give a good watering on everything while I got the pump running. And then we'll have 110 gallons in the barn, in addition to all the tanks in here filled up. And I'll be using those up before before we get to really cold weather here by the look of the forecast, so it should be okay. So that's just a general overview of what I'm about to do. I just got ready to hook the power up for the pump, so I'm just going to start filling this barrel right now. I've not wired the relays in on any of this stuff. That will be the last part. So pump is running. So quiet you almost can't even tell. Cricket is singing and rejoicing. Love that. And then I know I heard a few bubbles go in here. So the barrel is filling. So all the digital controls for from the Raspberry Pi will be done as the last phase of this. And I'll have to run another leg for sensors for these two sensors, and I'm going to run I don't know how many sensors, but definitely a few, at least 2, maybe 4 sensors in this bed. The coil that's going to do the heat underneath this bed is going to come out of this tank here, run across under the walkway like we do for the input side here, and then loop through this bed, and then that'll be covered with wood chips to distribute that heat evenly. And that should give us a nice warmed bed plant space, which should be ideal for these tropical plants. That in combination with a little bit more supplemental lighting, and we could actually be growing tropical plants year-round in here in their native comfortable environment pretty much. So that's always been sort of the goal with the greenhouse, to be able to have full environmental controls, and I'm finally back to doing some of the long-term planned upgrades. I now have kind of scrounged all the parts together. I was going to wait and get PEX tubing, but I realized I had all the fittings I needed, all the barrels I needed, all the parts I needed, and I really like not having to buy anything to do a project. That just feels really good to have it all on site. Okay, I've babbled on enough. We're filling the barrel, and I'm going to go get the rest of this operation up and running, get some water flowing. And my brother Chris always said, go big or go home. So, in keeping with that, I had a pipe sensor that I already made up, and I was looking at how to use that efficiently, effectively. So this is going on the output that goes to the coil for heating the bed, and that will tell us what the output temperature before it goes into the bed is, and that'll basically tell us, based on the bed sensors, how much heat we're actually able to dissipate into the bed from the coils. This is all set up, and I thought, you know, if you're going to have 2 tanks full of water and you might have a problem with the coil in the bed, it never hurts to be able to shut off the output of those tanks so you don't lose both tanks fluid while you're solving an issue. So I stuck a valve on it as well. This is an old valve from the ram pump. You can see it's had freeze damage, but I believe it seals when it's closed, so, and seals when it's open, so it should be okay. Alright, this barrel, how's that for timing? Just filled up to the top, so time to switch over and start filling this barrel. So, got that disassembled, bang bang, traded out for a valve that I know is good from out on the farm. You can see that's had a repair and a crack before too, but this one I know doesn't leak because I used it over the summer. So, before it becomes another crack valve, I figured I'd bring it in here. So, easy trade out, we'll switch this back in, then we can get on with business. Alright, new no leak valve in, eh? And let's make sure. We'll put some water in it. We are now pumping water. Yeah, it leaks in the transition, but not when it's shut off. And not when it's open. That's acceptable. I mean, it's not fantastic, let's face it, but hey, it doesn't cost anything, so it's acceptable. So this barrel will be full, and I'm actually going to go get the foliar pump started now and get some water flowing, because that's next. Looks like the first barrel has no leaks. That's very nice to see. That bottom bung was leaking a little bit when I first started filling it last night, but I went back and tightened it up, and seems to be good. Alright, carrying on. Okay, well, that was quite the ordeal. Water levels are still very low. We're barely getting some water into the pond, or into the intake pipe for the ram pump from the pond. But we're moving a little bit of water. Yeah. So I've been trucking 5-gallon buckets in just to get this bulk tank topped back up, and you know, to help supplement this really ridiculously slow water pumping from down below. Not a whole lot of water there, but we're getting some. And this is cold water now, obviously, so I'm going to heat it up before I send it to the barrels, because there's no point in sinking cold water into our barrels. So we'll just look at the chart quick. You can see we're tank 2 tanked off, so to speak, and where tank 1 is still hot. You can see tank 1 is at 150, and I'm going to bring on the script, just a manual pump on, and we'll throw some heat into that tank before we continue. So pump is on now, prime it up, primed, putting out at 130, 140 degree water. Yep, it's warm. So that should warm the tank up pretty quickly. And I'll refer you back to the chart in a few minutes after we've sucked some of that heat off. So starting to pull the new coil in here to go down on the floor. The hose, of course, is a little stiff from being outside. It's cold. So to cure that, I jacked into the hot output side of the thermal mass tank. We're going to run some warm water through that hose to loosen it up, and then we'll switch back to circulation. So yeah, that should make things a little easier. There we go. Much more flexible. Very nice. You see I started making the coil runs here. Now I'm going to pin that stuff in place with the potted plants for now, and then tomorrow whenever I have time and it dries out enough with the tractor, I'll come back with some wood chips and fill in over the coils. Okay, basic coil array laid. Comes out of the bottom of the tank and around and across, and then scoots back and forth across here, and then shoots back around the back side of the ginger tank and across, and comes back to here to return cold to the bottom. So now I just got to finish filling this secondary tank, and then we'll switch over to the fitting for the 1/2 inch, and we'll actually test circulating through the coil. I know these coils aren't pretty right now, but once I get all the technical side of this settled, I'm going to come back in here. I'll move all these plants off onto the walkway once I have walkway to do that on, and then I'll fill this with wood chips and settle these coils out nice. But for now, it's laid in so we can get it functional and tested and operational. So that's that. That feels really good, and I'm going to go ahead and finish filling this secondary tank up and get started testing, making sure we don't have any major leaks, etc., etc. Yeah, well, here we go. Real quick, I'll let you have a look at the tanks here. You can see where deheat dropped. You can see where the upper tank, the green line, has been dumping heat to the secondary tank. You can see the secondary tank where it dipped and then has come back up and has been rising slowly. I have the stove dialed back, as you can see here, It's just too hot in here. I'm sweating, man. But now that we've taken some heat off of that thermal mass, we can jack it up. And I'll just let you look at the BTUs quick too. You can see the dump off, etc., etc. Alright, rock and roll. Always some form of frustration on these projects. Gotta be patient and resilient and persistent. Do have a little bit more water flowing in now. Not tremendous, but I went down and cleaned the intake filter on the foliar feed pump. That definitely helped. So we're refilling the secondary tank here. And I filled up the barrels, rigged all the lines back up, finally found a makeshift fitting that would connect and not leak out of the bottom of the tank to go into the coil. Fired up the circulator pump for that, and watched the tank pressure build. Basically, you can see these tanks as they build pressure, they start to bulge out a little bit. This left tank has got a bit of a bulge to it right now still. So top input, no leak. Bottom output, no leak, or no significant leak. This tank, the input on this one has a little bit of a leak. There might just be some grit or dirt or something in that seal on the barrel bung. So I'll have to disconnect this and back that out and either get that seal cleaned and get it to hold, or maybe put some aquarium sealant in there or something just to get a good tight seal. Don't want any leaks. Bottom of this seems okay. The valve itself might be leaking a little bit. Might end up having to pick up a new valve for it, or scrap one from another project somewhere. Anyway, so did find pinches in the coil that was preventing some of the pressure coming out of the tanks. I think I found those pinches and got most of them sorted out. I'll do the rest of that when I go to lay these coils in a little bit better. I might be able to find or use, I might end up using a more appropriate tubing. I'd like something a little stiffer, but this is what I had that wasn't really awkward to work with. So we'll see how that sorts out as the coil, but most of the rest of the system is in. I did see as the pressure built in here that one of these sensors started to leak. I think it was this one here, but it might have been that one. But that was only under pressure. I probably will either back those out or clean them up and epoxy another layer of epoxy on. Or I may use aquarium sealant, something, I don't know. We'll see. But so far so good. Good progress overall today. Just a few little minor details to address to get it totally squared away. Did have water circulating through these and dumping back to the tank. I guess I can show you that quick. So over here on the reservoir tank, this is the pump that goes through to the barrels. This is the return line from the coil coming out of the barrels. And I'll throw power to it quick. Power it on. And you'll see water starting to flow almost immediately now. So that's good. We're not holding so much pressure in the barrels. Obviously I have to clip that end, and I'll probably find some way to affix it in place so it can't mistakenly fall out and spill, 200 gallons of hot water on the floor. But that's working, so that's good. Love it when a plan comes together. And I guess you can see the leak a little more here on this one bung. It's not a super leak, but it definitely needs to be patched up. But I would say that a couple of small leaks for first test run is not bad. Of course, I'm always hopeful for no leaks. I always try to go out of my way to be sure everything's clean and assembled correctly and all. But there's always some sort of a leak. Anyway, testing operation set up. Now we'll just tweak it in, and then we'll connect it to the relays on the Pi and automate it and collect sensor data back from it and chart it. Yeah, should be cool, man. I guess I'll just show this at full flow coming back now. Water's pretty chilly. Not all that warm going out at the moment. I imported a lot of cold water tonight, so, and I had the stove ramped back because it was just getting too hot in here. Okay, that's it for now. Enough babbling. Alright, well, me, I just can't put things down until they're fixed. Kind of anal that way. So, decided to pop this out and have a look-see. And it looks like there is not a seal in there. I could have sworn there was a seal in there, but clearly I was mistaken. So this is a fine thread, and this is a coarse thread. So I'm going to take the seal off the coarse thread, put it on the fine thread, screw it back in, and hopefully that fixes our bone leak issue. Never good to have a leaky bone. One seal. A little bit of dirt on it. So we'll just give it a rinse and a little finger scrub. That's not too bad. And how do we make a seal always seat nice and lubricate it so it seats nice and then not have oil everywhere? Did you know? Well, of course. A little bit of soap. So you just rub it on the seal like you do with an oil filter when you change the oil in your car. If you've ever done that. Anyway, that little bit of lubricant, because it's soap, it'll dry back out, but that'll provide a nice clean seat. So that seal and that seat will slide and tighten really nicely and easily, and then they'll stay. Let's do it. One and done. Obviously, eventually, I will come back and clamp these, even though they don't need it, just as insurance. By the way, that same tip with the Dawn works for getting fittings like this on nice and tight too if you want. Helpful tip number 123 from the Pharmacy Seeds Network. Okay, running circulator for a few minutes now. Good volume on return. Tanks are definitely under a little bit of pressure, but I don't see this bung leaking at all anymore. This one's still dry. This one seems dry. That one seems dry. We'll know better after these tanks get warm water pushed through them, and I should probably be able to tweak up some of these thread fittings a little bit. Once they do, they'll expand a bit, and then after that hopefully we'll be good. If not, we'll find and fix whatever leaks happen, and if it ends up being too much static pressure on these barrels, who knows, maybe we'll end up just making the barrels a reserve loop, and reconfiguring how we pump water through here. That one's leaking a little bit, but I'm not sure. Well, we'll see. 11:58. Tanks are recovering. Tank's full. I got the pump on in permanent mode. the stove running about 1 on throttle. It's putting out a lot of heat. I'm sweating again in here. So this is running relatively cool. It's the green line on the chart, so it's sitting down at 110 at the moment, and we're continuing to take heat off of that. That's fine. We're basically sinking it all to the thermal mass. And then once this tank gets warmed up a bit, probably won't get to any of this till maybe tomorrow night after work. Then I can circulate warm water out of this tank and into that tank. But I think I got most of the leaks squared away. I think I'm going to end up doing a T here, come off of that and go to a T and feed a double coil in here to reduce line resistance, and then probably pick up a T at the end here and return back on a single line. I don't know. Those are all things I'll mess with tomorrow. I've had enough for tonight. It's been like 6 hours of this, but pretty well set up for the upgrades. Just a few details to tune in. Alright, that's it for now. November 27th, back in the greenhouse. I didn't get home till about 8:30, so a bit of a late start. But before I left, I stoked the old stove up here with some nice maple and dialed it back to half on the throttle, so it would take a while to catch and kick in about dusk as the temperature started to drop outside. And sometimes I mess that up and it bridges and it doesn't go, but most of the time it works pretty well. So we'll just have a look at the chart here, and you can see that worked out about right. I think I stoked this up around 115, 130, and you can see the corresponding cold wood added drop in stove temp, and then you can see where it started to ramp up and then where it caught really took off, at least for that throttle setting, of course. And you can see the green line here, the thermal mass on top of the stove, climb out pretty steadily right throughout. Hit about 140. I came home and manually tripped the pump on. You can see the heat dump off pretty quick. You can see the exchange here on the BTU chart between the top tank and the bottom tank. And let's just look at the current temperature on the thermal mass tank. It looks like it's just about 101 degrees here. I'll zoom in on that a little bit. That's the more purple colored line here. So that tank is up to temperature. I did actually get back in here last night and wire in the relay on this. So now all I got to do is wire up the sensors on the barrels and the output sensor, and that'll complete the thermal mass part of the monitoring part of this. And then I still have to get back in here. It's raining out again now, so it's still mucky out there. I could go move wood chips in that, but I really just don't want to tear up the land. So I'm going to wait till it drains and settles, or we get a cold enough spell for it to freeze before I import the wood chips. But well, the coil testing was successful last night. I don't think we have any leaks here. I think we're pretty well set to go. We got a nice tank of warm water in TMAS tank 2. So I'm going to trip on the secondary pump, and we're going to start pumping some of that heat into these barrels and just get an idea how it acts. So these barrels together, they're 55-gallon barrels, but given the airspace that's going to be above this, I'm going to say they're probably closer to 45 or 50. We'll call it an even 100, just for simple math. And that's about an even 100, and this tank here is just about an even 100. I think it's like 98 gallons according to the geometric calculations. So about the same volume. So basically I should be able to exchange the heat that's in this tank into those barrels, and the cold water that's in those barrels into this tank, and then the next time I bring the pump on, we'll have a huge delta T between the thermal mass here and the thermal mass here, and we'll dump back off to this tank again. But basically we're just going to set up and go ahead and test this. So let's go ahead and do that. Real simple. I'm going to use the manual script here to bring on pump 2. And it's on. And and momentarily we should see water coming back the return line here. I hung this up so it's a little more stable, so it guarantees that it delivers back to the tank where it's supposed to. And in a minute here, I'm sure we'll see. Yeah, there we go. Water starting to flow as the tanks fill, and all the water in the coil starts to move. We're on and pumping and exchanging. Starting to come up to full volume. The other thing I realized in testing this last night was I think I can actually take energy efficiency gains out of this system. I'll explain. Using the barrels, as I mentioned before, we have airspace in the top of each of these barrels. And since air is very compressible and water is virtually uncompressible, it is compressible, but it's very, very little amount in volume per pressure unit, whereas air is very compressible. We actually have the ability to store pressure in these tanks and then release it over time. So what I found is that when I shut the pump off, this continues to run water through the coils for about another 30 seconds to a minute. So I could actually half the duty cycle of the pump and still be moving warm water through the coils. So I may play with that, experiment with that. We'll see. That wasn't the original intended purpose of the setup, but it's an interesting added benefit that I noticed already. And I may take advantage of that. It certainly could increase efficiency. I mean, it basically halves your power consumption to do the work. Of course, you're not going to move as much volume doing that, but given how efficient water is at heat transfer, we don't need to move that much volume to efficiently transfer heat. Alright, so that is working. We got cold water coming back out of that. And I know this tank is, like I said, about 101 average temperature. So we're putting 101 water in. I'd say it's probably coming back 60, 65 maybe. Probably 60. So big difference in temperature there. So while that circulates for a bit, I'm going to go ahead and hook up these sensors and get ready to plug that data into the database, and then I'll probably mess with the code for that tonight, and then we'll be able to actually monitor how many BTUs are in here, what the output temperature is here, and of course that could be compared directly with the average tank, or even as a more precise level, the upper tank temp sensor here, and then we would know exactly what our heat loss is. And of course, if we know what our gallons a minute is, which is really easy to calculate, then we can figure out exactly how many BTUs are being transferred a minute. So that's an interesting piece of data to be able to look at. Obviously, this all has to be set up into appropriate data collection, charting, database, etc. But, well, that's kind of all easy for me now. Anyway, this is this for now. We'll carry on as we go. Three sensors wired. I ramped the stove up to 1.5. And you can see how responsive it is. You can also see TMAS2 temp has been dropping. I shut the pump off, so it stopped dropping, but we definitely pulled some heat off. And of course, with the thermal mass on top of the stove climbing rapidly, I'm going to bring pump 1 back on and keep sequestering heat to the secondary tank. Of course, I am listening to Paranormal Portal in the background with my good friend Brent Thomas. He's the host, and that's some music he wrote, and it's awesome. If you haven't checked out the Paranormal Portal, check it out. Okay, carry on. Time to go write some code. Alrighty. A little bit of code updating done. We got the data logger updated, and I just installed that new code that I rewrote in place. And actually, we're gonna have to reboot, and then that will update the code that we're using. And then we'll see in the charts here, you can see, I guess I'll just show you quickly. You can see where I was testing the new code with the added BTU values, the added BTU storage. You can see where I was testing that script where it logged the higher values here, and you can see it partially in here. Some of this is glitches in the deheat because of the way I was collecting sensor data without going into a lot of crazy detail. Anyway, I'm going to reboot this now, bring the chart back up, and then we will see all the thermal mass that's being stored, both, well, in all three of this tank on top of the stove, this secondary tank, which I call T-mass 2, and then of course, as we sequester warm water into these two tanks, we'll see the BTU value of the two tanks, and we'll be able to see each individual tank on the temperature chart on the bottom chart there. And also we'll have coil out, which is this right here, and that'll tell us what the temperature of the water going to the coils, going to the beds, is at. And so the theory of this, again, I'll just say this again quickly for anyone who's not quite understanding what I'm doing here. We're sequestering about 100 gallons of warm water, so we're sequestering BTUs collected from the stove here, and then whenever this bed gets too cold, which will have temperature sensors in, we'll detect that the bed is starting to get cold, the feet of the plants are getting cold, we'll trip on the pump, and regardless of whether the stove is running or not, we will have about 100 gallons of warm water sequestered in here, so we'll be able to actually dissipate a pretty good amount of heat, even during a cycle where the stove is, say, off like wee hours of the morning and I'm not out here to stoke it. We'll still be able to keep plant comfort from sequestered heat. And then of course, if we don't need to use that for the bed, they will slowly release heat back into the greenhouse also. So we're taking advantage of the passive capabilities of it as well as active management. And we're doing that all with the Raspberry Pi, which is, this is the Pi 4. This is about an $80 board. And oh, I got one other thing I meant to add on my comment back to Brad from Grow the Farm Up. You will want the Easy Connect on here. This is like a plug-on that goes onto the GPO header that gives you access to screw terminal all your sensors in. That makes a big difference for connections. Well worth the extra 21 bucks. Anyway, the Pi that's underneath this is a Pi 4. It's 4 gigs of RAM. That's about an $80 board, and it has all the GPIO on it. It has monitor outputs. It has USB 3.0 gigabit Ethernet. It's actually a pretty robust board, and I run my charts on it here, and I'll also listen to music and watch YouTube and whatever while I'm here working in the greenhouse. So very flexible, powerful desktop computer, but also capable of GPIO, I2C, data logging. It acts as a pretty robust MySQL server. That's what I'm collecting all the data to. I could go on and on, but you get the idea. Let's get this reboot in and watch the chart change. Alright, rebooted, chart back online. So if you ignore the glitches and just look on the new data logging here for the last couple of minutes, you can see all the temperature data coming across here. Coil CL1 is the first tank and CL2 is the second tank, I think. Over here you can see the BTU gain that we've taken with that already. And like I said, I had the pump on for a little while, so I was moving some warm water in there. Looking at, there we go, yeah, CL1 and CL2. So that's these two tanks right here. CL1, CL2. And they're sitting at about 70. Is that right? oh, I'm sorry, closer to 90, 85, 90. So I've been moving some water into them, but enough of my babbling. Now that we can log the data, let's turn both the pumps on. Pump 1. Oh, pump 2. There we go. Both relays are fired. You can certainly hear it in the audio amplifier because I don't have any ferrite beads on here yet to suppress noise. Those pumps are a little bit noisy RF wise. But you can see the hot coil is going, dumping hot water from the upper tank here. And the second one's going now. We're starting to move a little bit of water. That volume will pick up shortly. And that's relatively cold water coming back still. So now what we'll see in the chart is we'll see the thermal mass on top of the stove drop off, and then I don't know, we'll see what happens with the other one. I imagine the other one's going to drop in temperature as well. So for reference on the chart here, this purple line right here is the secondary thermal mass tank, I believe. Yeah. And so that's sitting at about 90, and coil 1 and coil 2 are not too far from that. But as we dump heat from the green line here, which is the thermal mass tank on top of the stove, you're going to start to see these temperatures come up. The thermal mass tank as well as coil 1 and coil 2 as we pump heat into them. Just so you can kind of understand what's going on here. And you can see we're basically at full volume now. We're turning water back from the barrels. So we're pumping the coolest warm water out of the bottom of this tank. I could eventually raise this pump up a little higher, but I kind of want to pump relatively cooler water out. I don't want water too hot in this bed and end up almost cooking plants. I don't know how well that's going to balance. I imagine it's going to vary greatly with the outside temperature, but we'll see, because now that I got all the wood chips around and the insulation up, we're going to have a massively warmer greenhouse already with that. But this system will really add a lot of benefit to plant health and comfort. And I'm sure that a few more leaks will develop over time, and I'll have to figure out how to secure those a little better. But for now, this tank is relatively warm. This one's got a little bit colder water in it, but we're exchanging. I think that pump moves about a gallon a minute, so basically in 100 minutes we could exchange all the water in both of these tanks and have hot water into it. So we'll figure out how to manage the efficiency of that with the pumps as we go. But for now, the system is installed in testing mode, and we can log the data from it. And then there's just details to finish up, filling the beds in, leveling and evening out the coils a bit. And then I'll have to wire in, I'll probably wire in like 4 more temp sensors in the bed in 4 different locations down the bed, so we can kind of see how that works. And I probably will come back and split. I had to clip out a kink section of this coil. I'll probably come back and split a T in here and come right off of that barrel into the T, and we'll split into 2 coils under the bed to be a little more even in uniformity in heat distribution, and also to reduce static line resistance, which will help take some of the head pressure off of these barrels when the pump is running. I think you can see probably the bulge in the first barrel is a little bit bigger than in the second one, and that's really about head pressure that's being pumped in here. There's a pretty good amount of pressure built up in that barrel before it starts to overcome the line resistance here. I may also change this out to a 3/4 line, a good size 3/4 line to come across to help lower total head resistance as well. Just some logistics I thought I would talk about. Anyway, coming back from the T, I'd probably come back to another T and then run a singular line back through, just to not have 2 lines to manage coming back. I may wrap that around the base of the ginger tank here to help keep the ginger at a more comfortable temperature. But again, we'll have to see how much heat performance we actually get. For now, I'm going to modify the thermal script that controls the pumps to include checking these tanks, and we'll take them to probably say at least 100 degrees, and then we'll probably emergency cut out at 100, maybe 120. I don't want them getting too hot since they are plastic tanks. My understanding is this type of plastic is rated to 160 Fahrenheit. I don't really want to test that in here. That's some really hot water, and that would burn me pretty good and certainly would do damage to plants. So we're not going to push the extreme on that. I think as cold weather and winter comes on, it's going to be harder and harder to get these to go up to a temperature that's really hot and stay there, but we'll find out. Well, I think that's basically it for now. I'll probably grab another chart clip or two, and then we're going to call this project Phase 1 installed and in testing mode. So that feels really good. This is something I've wanted to add and build into a greenhouse for eons and eons and eons, and then I've had the idea for this particular greenhouse at least the last 5 years in my head, and so it's nice to finally see this come to fruition. Gotta love when things come to fruition. Just saying. Just saying. Anyway, I'm really excited and stoked, if you can't tell. And I hope you found this interesting or informative. And I hope you'll continue to watch the Pharmacy Seeds Network. Once I get this system mastered, of course, this will be incorporated into the Part 1 into the Build Your Own Greenhouse series, in which I go through many of the details for building your own greenhouse and many of the logistic considerations you have to take in order to build a greenhouse. A lot of people think building a greenhouse that can sustain plants throughout the winter is easy. I can tell you, it's not. There's a lot you need to understand and know, and I'm more than happy to share that information that I've learned with you, so you can be armed going into the future with good information and make good engineering decisions. Thanks for watching the Pharmacy Seeds Network.